Good morning, Professor Basil and fellow colleagues. My name is Ayman Ali, and today I will be discussing disc clutches, their components, and how they work. In order to fully understand today's topic, I will be explaining some background information regarding disc clutches, the construction of both types, their components, their analysis, and lastly, the types of applications they are used in. So, for some background information, the main objective of disc clutches is to maximize the friction coefficient and keep it uniform over a wide range of operating conditions, all while minimizing wear. The main function of a clutch is to permit a smooth and gradual connection and disconnection of two members sharing the same axis of rotation. Disc clutches are all of friction type, meaning they depend on friction to function. All friction clutches are designed to satisfy three basic requirements. Firstly, the required friction torque must be produced by an acceptable actuating force. Secondly, the energy converted to friction heat must be dissipated without producing destructively high temperatures. Third and lastly, the wear characteristics of the friction surfaces must be in a way such that they give acceptable life periods. Now, for the construction of clutches, specifically single disc clutches, as seen in the figure below to the left, that is a simple disc clutch with one driving surface and one driven surface. Both surfaces share the same axis of rotation as stated before, which in this case is a shaft used for provision for axial movement. This leads to a driving shaft and a driven shaft. In the middle, a friction lining material is presented as the driving friction between the two surfaces develops when they are forced together. To the bottom middle, a cross-section of the single disc clutch is seen, where the ring element is subjected to clamping pressure, while the inner and outer radius of the single disc clutch and the width of the ring element are observed. To the bottom right is a picture of a real live single disc clutch just for reference. Moving on to the construction of multiple disc clutches. As seen in the bottom left figure, instead of one disc and two friction surfaces, there's actually 7 discs and 6 friction surfaces in total. The discs are split into 4 driving discs and 3 driven discs, that again share the same axis of rotation, which is a shaft leading to a driving shaft and a driven shaft. As observed, there is also a pressurized oil chamber to engage the clutch along with the inner and outer radius of the multiple disc clutch. These clutches can be designed to operate both wet and dry. Automotive clutches for standard transmissions operate dry, while most multiple disc clutches, including the ones used in the automotive automatic transmissions, operate wet. To the bottom right is a picture of a simulated multiple disc clutch just for reference. Now, for the components of a disc clutch and how they work hand in hand together, to the bottom left is a labeled figure of an automotive type clutch used with standard transmission. As shown, there are many components such as the flywheel, clutch cover, and pressure plate which all rotate with the crankshaft. There's also a series of circumferentially distributed springs, or assorted cone disc / diaphragm spring that force the pressure plate toward the flywheel, clamping the clutch between them. The hub of the clutch plate is spline connected to the transmission input shaft. The clutch is then disengaged by depressing the clutch pedal, which rotates the lever marked to release. This pushes the clutch release thrust bearing against a series of radially oriented release levers that pull the pressure plate away from the flywheel. In this specific clutch, there are 2 driving surfaces, the flywheel and the pressure plate, and 2 driven surfaces, which are the 2 sides of the clutch plate. To the bottom right is a picture of a simulated disc clutch, which is color-coded to specifically point out the components such as the flywheel, clutch lining, clutch disc, gear casing, pressure plate, plate spring, thrust bearing, clutch lever, drive shaft, and lastly, the fulcrum for a better visualization of the part. Now, for a deeper understanding of the disc clutch and its components, the figure below displays a diaphragm clutch. The flywheel is connected to the engine through the crankshaft and features external teeth which are used to start the engine of a vehicle. When the car keys are inserted into ignition and turned, the engine is started with the help of a pinion and the battery, which is then run by fuel. The flywheel is equipped with a friction surface, and so is the disc clutch on both sides. The friction surfaces are made of ceramics or substances that cause for a high coefficient of friction. When and only when both friction surfaces are connected, the clutch disc rotates. The disc clutch itself is also made of important subcomponents such as the hub, cover plate, and the rivet. The clutch also contains springs that dampen shatter to achieve an easy operation and reduce impact to the gearbox during the process. The disc clutch is connected to the gearbox through the gearbox shaft. The pressure plate is connected to the flywheel and is used for engaging and disengaging the disc clutch. A clutch release bearing is positioned in the front of the diaphragm spring. When the release bearing is pushed into the spring, the inner portion of the spring is moved in the direction of the disc clutch, whereas the other portion of the spring moves oppositely. Now, the clutch is disengaged as the pressure disc is mounted in a flexible manner to the casing. So the clutch disc can be locked between the flywheel and the pressure plate when the release bearing is released as it is pushed into the diaphragm spring. Through this whole process, the mechanical energy produced by the engine is transmitted to the gearbox, and the clutch release bearing is released, and the clutch disc is now engaged. Now, moving on to the analysis of disc clutches. The first set of equations used in this unit are displayed at the bottom left, which are based on the assumption of uniform distribution of interface pressure, which is valid only for new, unworn, and accurate clutches, which will be studied and used in greater detail within this unit. The second set of equations used in this unit are displayed at the bottom left, which are also based on the assumption of uniform rate of wear at interface, which is valid for worn clutches, unlike the first set of equations. This is the case as new clutches would have the greatest initial wear at the outer radius, but after the initial break-in, the friction lining tends to wear at a uniform rate. This second assumption gives a lower calculated clutch capacity than the first assumption in the previous slide. Once again, these equations will be studied and used in greater detail within this unit. Now, moving on to the last equation, which is displayed in the top right. This equation represents the ratio of the inside to outside radius. It identifies when the maximum torque for a given radius is obtained. The last piece of analysis includes the two tables seen below, which are critical to solving the two sets of equations stated above. They are both used to obtain either the allowable pressure for various friction materials to the bottom right table, or the approximate data relative to coefficients of friction to the bottom left table. Lastly, the applications of disc clutches. Disc clutches are used in a vehicle's manual transmission. They engage and disengage power from the engine to transmission. In some high-performance applications, a multiple disc clutch is used to harness the high amounts of horsepower and torque produced by the engine directly to the input shaft of the transmission. Vehicles of today normally use a clutch to transmit power produced by the engine to the gearbox. They mainly rely on friction clutches, such as the single and multiple disc clutches, which is why they are used in any manual, speed cars, motorcycles, and boats. Thank you very much, Professor Basil and my fellow colleagues, for your attention, and I hope you now have a deeper understanding on disc clutches, their components, and how they work.